number 6. And by the way, there are 12. Yeah, 12 different ways to make those if you're so inclined to try to figure it out. Okay, number 8, then this one says, how many of you have a book? Everyone have a book? Oh, does anyone have a book?
Mine's on order. Come today, come in 2 weeks.
All right, well, let me see whether I can draw this thing. So number 8, what they're wanting to know is, it says each of these exominose shapes can be folded to form a cube. After folding, what number will be directly opposite of 1? So what they have for the first one, and so then let's remember, here's 1, 3, 2, 4, 5, and 6. Now you're supposed to fold that and then say what number, when you fold, it's going to fold into a cube, what number is going to be opposite this one?
Would it be 4?
Yeah, 1 and 4. Because what you do, the 1 would fold down, right? The 2 would fold down, and then the 4 would come around. So you'd have 1 and 4. This is 8A. And B1. Terrible when you have to draw this. What doing is, this is 1, 2, 3, 4, 5, and 6. And so once again, what's opposite the 1?
3.
Does everyone see that? 1 and 3? 3, that long string just goes around, right? 1 and 3. That pretty easy to see. Yeah. All right, the C one. So once again, what's opposite of 1? Okay. All right. Yeah. That is right. It's 1 and 5, but it isn't C. That's actually C on 7. This is 7C. I drew the wrong one. But it is 1 and 5. Okay. It says determine if exactly 6 squares of the 3 by 3 grid shown can be shaded so that no 3 shaded squares line up horizontally, vertically, or diagonally. So this is 10. So I can go. So you're supposed to determine if exactly 6 squares of the 3 by 3 grid can be shaded so that no 3 shaded squares line up horizontally, vertically, or diagonally. Anyone have an idea?
So you're shading 6 squares.
Yeah.
But no 3 can be attached in any fashion.
No 3 can be attached diagonally, no, horizontally, vertically, or diagonally.
And you have to shade 6 squares.
6 of them. Anyone have a,
I don't think that's possible.
do you think it's possible?
I think it's the corners.
Okay, well, it's not gonna be all 4 corners.
No, I know that. Do the top middle, the top left, and the mid left.
This one over here, mid left.
Excellent.
And then you go down to the bottom and do the exact same.
He's right.
You can't do the left, you'd have to do this one.
Right, that one, the most right, and then middle right.
That's how you do it. Or you could flip it over, you know, yeah. That's 6 squares, no 3 linked horizontal, vertical, or diagonal. Okay. 12. It says how can 18 cubes be stacked so the minimum number of sides is exposed? So 18 cubes stacked so the minimum number of sides are exposed. Well, if you pile them either either 2 high and 3 wide, or 3 wide and 2 high. If you do something like this. We'll go 3 wide, 2 high. So you see there's 9 on a layer, right? 2 layers. Or else, you could set it up on end. Go 2 wide. And then you'd have the minimum number of sides exposed. Now, the next thing says, how can 18 cubes be stacked so the maximum number of sides are exposed?
A pyramid?
Pyramid? It'd actually, the way you do it is to build a wall. I mean, and I don't know that I'm gonna have enough when I space this out right. I want to have 9. Is that 9? Then you have it go back.
Well, for that matter, why wouldn't you just put all 18 in one row?
Well, then it says stacked. Are you stacking it if you run it out? 18 in a long row would be, maybe that is. But, depends upon how you would say stack. That would be if it has to be stacked, then it has to be in a wall form somehow, either a wall 1 high. I wonder if you're wonder if your idea of a pyramid would actually get more of them. You had one on the top. So your idea might be more correct. Then you'd have to do 3. That might. Boy, this thing's so sensitive if you touch it. I'm just kind of rethinking what I did. Maybe you're. We go out. Now, how the heck what do we got? We got 8, don't we? All right. That's not, I'm not throwing, yeah, I'm throwing that down, right? That's 6, that's 15. We couldn't make another row, could we? Unless we wiped out what? To make another row, what do we have to have?
Right, you can go 6, 5, 4, 2, 1. But I think it's
4,
not
5, 6. That's
a
7.
good answer.
If we went 9, 9 would be the next row. I mean, we could take some off the top, that's what I was saying. Do we have some more exposed sides by doing it that way? I think we're gaining these sides on the inside end of the pyramid. Are we losing any? We're not losing any. That's 1, 2, 3, 4, 5, 6, 7. So that's 9. 9 and 7. Isn't that the way it goes? 9, 7, 16. How many total do we have? 18? Well, I mean, we could just take it off the top of the pyramid. And we gain the ends that we have. So here we have 4 blocks that have 3 sides exposed. here we'd have 1, 2, 3, 4. So we'd have 9, 16, 17, 18. We have 2 blocks on top, and we'd have those 2 blocks. So we'd have 1, 2, 3, 4. We'd have 6 blocks with 3 sides exposed. That would work. That would gain us more than this one, because here we'd have 4 blocks.
So what's the middle right or?
And we'd have to do away with this block, this block, this block. That one, that one, that one. That'd be a better answer. Okay. Number 14. That one is just going to be. All right. Looked at it and did it. That's just too difficult to show. I can kind of tell you how. It says determine how to cut a triangle region into 22 regions. Kind of the way you do it. And you start with a diagonal from here up to here. Then you move this one over just a little bit, and then you go right in here. And you just keep working yourself along the bottom and along the top, and it'll give it to you. Then to try and count them, but that'll get you the most if you do it that way. You understand what I'm saying?
I do. It's not what I was thinking. I was thinking of bisecting each triangle over and over and over.
Yeah.
I'm not gonna argue with the
Yeah.
textbook.
The textbook shows that. Okay, 16. It says an organization has access to 10 rectangular tables with each will seat 4 people on a side, 1 person on each end. For an awards banquet, the tables are to be lined up end for end, form one long table. How many people can be seated at this long table?
How many tables?
10 tables. So,
4 on each side.
well, 1 on each end, 4 on each side. So what?
42.
No, more than that.
10 times
I mean,
8,
here's-
never mind, 82.
God dang it. 82 is what's correct. And then there's these in between on the tables. So what you have is you have this table right here will have 9 on it, right? 4 and 4 and 1 on the end. And this table has 8, and all the ones in between all the way over here has 8, and this table has 9. So what you got is these 2 tables have 9, so you got 2 times 9 plus that leaves out of 10 tables, that leaves 8 of them have 8. So you have 18 plus 64, which is 82. Okay, people sitting at the tables. That one's pretty easy to show what. No, it's saying how many people could be seated at a long table with from 25 of the rectangular tables. So you still got this 2 times 9, because the end is going to have, the 2 ends are going to have that, but now the middle you have 23 times 8. So you got 18 plus. Did I multiply that out right?
202.
So that would be how many? You had 25 tables, and you arranged it in that order.
You get it to a tree.
What?
You get it to a tree.
I-
Tree.
Oh, 23. Where are you getting the 23?
Oh, see, if there's 25 total tables, total tables, 25. So there's 2 on each end, this one and this one, that has 9 people at it. And then there's 25 minus 2 is 23.
Oh, okay.
So you have 23 with 8 in it. So that's,
Professor, are these assignments now up on Sakai? They weren't the other day.
I don't have I'm recording this right now. Okay, so when I get to it, I don't know that I'm gonna do it every day. I'm gonna put the recordings up on YouTube. And so it's not gonna be on Sakai. You have to go to YouTube and then just go my name, or just Google my name. And you'll go right into my YouTube account. And then you look for the date. And then you can see all you'll see is, you'll hear my voice and you'll see that voice.
Lessons.
Yeah. That's what's gonna be there.
How do we submit assignments?
You don't submit assignment. You go, what I'm gonna do is next Wednesday, I'm gonna have a quiz, and it'll come from the odd problems. And I will take odd problems from the ones that, we successfully did in class. Like that pentomino one that had, if we weren't successful in getting it in class, we won't do it. But anything else that we successfully do in class, like this one, I might say, whatever because what happens is 15, let's see, this problem was, which number? This problem was 16, so 15 and 17 potentially. 15 would probably be a problem like it. So they're staggered that way. There's a couple, 3 problems in a row that are kind of
Similar.
alike. Yeah. So then you kind of do those, and if you know how to do those, that's what I'll let. Yeah. So they're going to have, these are going to have to be word problems. I'm going to have to make a statement, and then you'll have to. But I'll just take the statement out of the book. All right. So 18. Does that clear up? I don't want to pick up homework. You guys are at the level in your career. You know what you have to do and what you don't have to do. If you don't have to do the homework and you can get whatever grade you want out of this class, you know what you got to do. But I'm telling you the way I'm going to run the quizzes and the tests. 18. Says use the toothpick arrangement in problem 17 to do the following. So, the toothpick arrangement. This is what they have. Okay, one too many. No, they were four. Okay, that's the arrangement. And they say, and do the following. Remove exactly 7 toothpicks to leave 2 squares. You want me to give you some kind of a hint? You'll have to take toothpicks so that the left or the right hand side of that, that rectangle, thank you, is gone. And then with what's left, you'll have to make it so that there's 2 triangles in what's left. Squares. Yeah. Thank you. You see it? It don't make any difference. You take either end off. And I'll just take this end off. I'll take 1, 2, 3, 4, 5. Now you see you got 1 square, and you got to have it so that you have 2. I mean, you actually have 5 squares there. So you got to get it so there's just 2. So you're going to have to take 2 of the toothpicks off the inside so that you have a big square and a little square. And there's several ways you can do it.
Oh, I see, there's a square within a square.
Yeah.
Okay.
And that makes your 7 toothpicks off. That isn't just the only way you can do it. You can take the other end off, or you could take this one and take any other 2, the 2 squares in the upper right, or the 2 squares in the lower right, or the 2 squares, 2 toothpicks in the upper left. There's several ways, but it ultimately comes down to that. Okay. Now, I want to see if I can. The question is, we have to do the B part. I'll just redo this. So this is the A one. B part. Now they say remove exactly 5 toothpicks and leave 3 squares. And there should be no leftover toothpicks. 5 toothpicks. No, remove exact, oh no, I read 17. Remove exactly 7 toothpicks. This is 18. Remove two toothpicks and leave 6 squares. That's what this B part is. 2 toothpicks and 6 squares. Let me give you a hint. Take 2 toothpicks off of one of the corner squares. So that you eliminate a square in a corner.
That would be 6 squares, but you have to remove how many?
2.
Just 2?
So you'd take, if you did it here, it'd be either any corner, right? So then you'd have 1, 2, 3, 4, 5,
And one big
and then this big one here. That'd be your 6. Okay. And it says, this one is and the instructions say, can you trace the following figure without lifting your pencil and without retracing any lines? If so, explain how. If not, why not? Just to facilitate time, you can't. So why not?
the Euler's theorem, the vertices and whatnot, it tells right off the bat whether it's possible or not. Although I can't remember that for the life of me.
It has to do with these 4 vertices. Remember, you have to trace it out without retracing a line. You see, there's 3 lines that go away from that one point. So you can come into it twice. But when you come into it, you will already have traced it. Like if you say you start here and you go 1, 2, 3, 4, you wouldn't want to do it that way. So what you'd want to do is then you try to do this. You try to do 1, 2, 3, 4, 5, 6, 7, and you can't. You've gotten around there. You go 8, 9. So you're trapped. You can't do it. It's because of those vertices where you're leaving the thing. You just cannot. You can't get to that without retracing a line. Because if you went 9, 10, you're hooked. You went 9, 10 here, you're hooked. So the answer is no. And the reason is that there are 4 points where 3 lines meet. All right, so let's look at. I wish we could. I'm gonna try and draw this one next one out because it'll show you one where you can do it. But I don't know what I can do. Okay, that one you can do. If you, let's just say you start here, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You see, you just keep going. You can make that. And you go 16. You just follow that pattern around and you'll be able to trace it without recrossing a line or picking your pen up off the paper. All right. Number 24 says, Greg has 102 meters of fencing. He will use all the fencing to enclose a rectangular region that is 4 times as long as it is wide. One of the longer side is bordered by a river, so the side will not be fenced. What will be the dimensions of the region? This is pretty much a word problem algebra type. So you have 102 meters of fencing. He will use all the fencing to enclose a rectangular region that is 4 times as long as it is wide. So what are you going to do? You're going to say if the width is here, then this is 4 times the width, right? And this is width. And one of the sides borders the river, so that the side will not be fenced. What is the dimensions of the region? So you got the 100,002 meters of fencing, so it's just going to be 6W, right?
6W. Is it 102 or 1,002?
1,002. I said 102, but it's 1,002. So the width is going to be 1,002 over 6. Whatever that number is. 167. And then 4 times that 167 is going to be 688. So that's the width, this is the length. That's just kind of, that's a problem that you did in algebra. Okay. don't have time to do another, I was only gonna, 26 and 28 in that section were the only other two. When do you people get your book? If you look